Okay, so we are now looking at the other topic, which is called aggregate planning. Okay, so aggregate planning. This is in production and operation management. So we have aggregate planning. So in general, aggregate uh, planning, okay, involves the following. So workers required. So workers required here. The production units required. Okay, so production units required. We also look at the, of course, the workers required, the production workers hired. So workers hired. We also look at workers laid off. And then, of course, we also look at a hiring cost. So hiring cost. We also look at layoff cost. Okay, we also look at subcontracting cost. So subcontracting cost. All right, so this is what goes on. And then we also look at the stock out cost. Stock out cost. We also look at the overtime cost. Of course, we also look at the regular production cost. Okay, so this is on what goes on getting down to regular production cost, or simply called the straight time cost. Okay, so this is also called the straight time cost. So there are two strategies that are involved. Two strategies, okay, involved. So the first one is the chess strategy. Chess strategy, or matching demand. So that is the first one. So this is a strategy where the firm, okay, vary size workforce. Okay, this is the strategy where the firm vary size of workforce in order to have production rate that matches demand. Okay, so that matches demand. So the firm varies size of workforce simply by hiring and laying of workers. Firm vary size of workforce simply by hiring and laying of workers. As a result, the firm incurs hiring and laying of costs. So the firm incurs hiring and laying of costs. So the cost of the costs of chess strategy, we have hiring, so hiring cost. Of course, we have the layoff cost. So we have the layoff cost. Then the other one is straight time cost. So straight time cost. So meaning all these costs, aggregating them, we are getting the total cost of the chess strategy. Okay, so no subcontracting. So no subcontracting, no stock out, so no stock out cost, and of course, no overtime. Okay, no overtime cost because the firm would have hired as many workers as possible, would have laid off as many workers as possible. Then the second strategy is what we call pure level strategy. So pure level strategy, we are simply saying for pure level strategy, here the firm, okay, the firm maintain state workforce and production. State workforce and production. So what we are simply saying is that there is no hiring and laying of workers. So there is no hiring and laying off workers. Okay, so this is what we have concerning the pure labor strategy. Okay, so if the constant workforce cannot produce to meet demand, then so if steady workforce cannot produce, so if the steady workforce cannot produce to meet demand, okay, so if the steady workforce cannot produce to meet demand, then the firm should incur either the following costs, then the firm should incur either of the following costs. So the firm should incur either the following costs, meaning that they can go for either overtime, they can go for subcontracting, or they can just simply say they don't have stock and they have the cost of losing business where they have the stock out cost. So stock out cost. So these are the costs of the pure level strategy. Costs of pure level. So cost of pure level. So cost of pure level strategy. Okay. So cost of pure level. So the first one that we have is hiring. So the first one that we have is it can either be overtime. There's no hiring here, so overtime cost. We can have subcontracting. You have the stock out. And the straight time, regular or straight time cost. Regular or straight time cost. Of course, we can have the holding cost. So these are the costs of the pure level strategy. So we can look at this example here where it says explain five variables that the operation manager can manipulate to meet short-term capacity. So they can manipulate workforce. So five variables that manager can manipulate. Five variables that manager can manipulate. So we have they can manipulate workforce, meaning that can hire, we can fire, they can subcontract if you want to meet the short-term demand. They can have a backlog. They can allow overtime. So these are some of the five factors that management can manipulate. So they can have a hires off and lay off. All right. Can manipulate workforce by hiring and firing. Okay, so this is about what we have. Then we have this question here, which is on aggregate planning. It says computer products produces printers and flash disk units for personal and small businesses. The sales director is looking over next year's sales forecast for these products and will be dropping an aggregate plan for the plant. So we have those ones. So they are simply saying these are productions. Then they are simply saying that um, we have the quarter one, quarter two, quarter three, and quarter four. For the printer, we have two products, the printer and the flash disk. Okay. Then the productions are though as follows. For the printer, we have 1,000 quarter one, 1,200 quarter two, 1,400 quarter three, 1,200 quarter four. For the flash, we have the 2,000 quarter one, 2,400 quarter two, 1,800 quarter three, and 1,700 quarter four. And then to have ample machine capacity exists to produce the forecast. Each printer takes 20 hours to be produced, and the flash takes 15 hours to be produced. So this is what we have. So we need to find the aggregate number of hours per quarter. Aggregate number of hours per quarter. So meaning that as we go down to the solution, we are going to have quarter one, quarter two, quarter three, quarter four. Okay, so meaning that from here, what we are simply saying is that we are going to have printer hours, then the flash hours, and then we can get the aggregate hours. Okay, so here we are going to have aggregate hours. Okay, so aggregate simply means the sum of hours. So aggregate hours, print hours, and then what else you have the flash hours here. So this is about what goes on. So each printer requires on average 20 hours, or 20 multiplied by 1,000, then 20 multiplied by 1, 2, Then we have also 20 multiplied by 1/4. Then we have also 20 multiplied by 1,200. Then getting down to the flash, we have 15 multiplied by 2,000. Then here again 15 multiplied by 24. The other one is 15 multiplied by 1/8. The other one will be 15 multiplied by 1/7. So you can now find the hours here. So the first one here is 20,000. So we're going to find the aggregate hours. So 15 multiplied by 2,000. So it's 30,000 here. Aggregate hours will be 50,000. Wiki quarter one. 20 multiplied by 1, 2. So this is 24,000. So 15 multiplied by 2, 4 is 36,000. So plus 24,000. So it is 60,000. 20 by 1, 4, 28,000 is what we have on this quarter 3. 15 by 1, 8, 27,000, which is giving us 55,000. So 20 by 1,200 is giving us 24,000. Then the other one is 15 times 17,017 is giving us 25,500. The aggregate hours here will give us 49,500. 49,500. So this is about the aggregate what? The aggregate hours. So we have answered the first part of this question in terms of computing the aggregate number of hours per quarter. Now the question continues, if each regular worker works 520 hours per quarter, how many hours will be required to meet quarterly demand? Okay, so we are going to sort out that one just soon. Okay. So what I'm simply saying is that for number 2, we have the quarter 1, quarter 2, quarter 3, quarter 4. So for these quarters, we have the aspect where we are now simply saying we are getting down to aggregate hours. So aggregate hours. So the first one is 50,000. Then the other one is 60,000. Then the other one is 55,000. Then the other one is 49,500. Then employee hours per quarter. So your employee, okay, hours per quarter. So it's 520, 520, 520, and 520. So number of workers, we can divide it to find number of workers required. So 50,000 divided by 520, it's 96. The quarter two, 50,000 divided by 520 is 115. That one is 55,000 divided by 520 is 106. Then the other one is 49,500 divided by 520 is 95. So these are number of workers according to this question. What that says, if a worker works 520 hours per quarter, how many workers will be required to meet quarterly demand? Then we have to answer the last part of the question. It says it costs 1,000 to hire a worker and 400 to lay off a worker. Okay? And then the Computer Products Limited works the same number of days each quarter, 13 5-day weeks. Evaluate the aggregate plans for the next year using labor capacity with inventory and matching demand, which is cheaper. So beginning inventory is 0 printer and the 450 flash disk units in the level capacity and 0 for both in matching demand. Assume that quarterly demand pattern repeats from year to year. Okay, so meaning that we can go for matching demand. So the number of workers we have, okay. So matching demand, we are going to have our matching demand. Okay, so you have quarter one, okay. And we have quarter two, quarter three, and quarter four. So we are going to produce as per demand. So our demand here, we can go for a demand. Then we have the beginning opening stock, production, okay, so we have the production, the number of workers here. Of course, can present it properly here. So on matching demand, So matching demand, we are going to have, okay, the quarter, then we have quarter 1, quarter 2, quarter 3, quarter 4. Then we have the other aspect here where we get to our demand, okay. Then we can go for our beginning stock. So beginning stock, we have our production, then we have number of workers, workers, hired, then workers laid off. So this is about what we have here. So our demand, the total demand, aggregate demand for these products is 3,000, which is 1,000 plus this is 3,000. We have the demand of 3,000, the total demand. The demand here is 1,200 plus 24, which is a 36. So we have a 36 here. Then the other one that we have in the other quarter is 14 plus 18, 32. Then the other one that we have is 12 plus 17, which is a 29, which is a 29 here. And then the beginning inventory is 0 for both in matching demand. So 0. So we are producing to meet the demand. So produce a 3,000, the 36, the 3,200, the 2,900. The beginning stocks are zeros. So the number of workers, we had 96. Then we had 115. We had 106. Then 95. Now, quarter demand pattern is repeating from year to year, meaning that the ending quarter 4, we should have had the beginning stock, the beginning workforce in quarter 1, we should have had 95, but we have 96, so meaning we had 1, because the demand should repeat the closing workforce for quarter 4, which was supposed to be the opening stock for the beginning quarter 1. We should have had 95, because usually the closing workforce for the last quarter is the opening stock for the other quarter. All right, so here we hired 1 because we were supposed to open with 95, because the closing quarter was supposed to be the opening. So there they hired 96 minus, so they had 19, 96 minus that. Here they didn't hire, they laid off 115 minus 106, they laid off 9. in quarter 3, and then 106 minus 95, the rate of 11 in quarter 4. So total workers hired, total workers hired is equal to 20. Total workers laid off is equal to 20. We can find the total cost. Total cost. So meaning our hiring cost is equal to our layoff cost. We can find from here. Hiring cost 1,000, layoff cost 500. Hiring cost is actually okay. So this is on according to what we have. So the hiring cost would be 20 workers multiplied by $1,000, which would be equal to $20,000. Then the level of cost would be 20 workers multiplied by 500, which is equal to, so 20 workers multiplied by 500, which is equal to 10,000. So meaning that here we are going to have a total cost of $30,000. So this is the total cost of the matching demand. Then we can get into the level strategy for level strategy now. Level strategy. Under level strategy, we can go for level strategy for printers. So level strategy for printers. So for printers, we have quarter 1, quarter 2, quarter 3, quarter 4. So meaning that our demand here, okay, so the demand that we have here is actually equal to, so for the printers, we have 1,000 quarter 1, 1, 2, 1, 4, and then 1, 2. Then our beginning stock, okay, beginning stock. Then we can go for production, which is on level production. And then we can go for ending stock. So we can go for our ending stock. So our ending stock formula here, ending stock is equal to beginning stock. So beginning stock, then plus production, then minus demand. Okay, then our level production, this one here, since there was a quarterly, the repeat in demand pattern, it's a summation of demand over number of periods. So which means it's 1,000 plus 1,200 plus 1, 4, then plus 1, 2, and divide these ones by 4. So meaning that 1,000 plus 1,200 plus 1, 4 plus 1,200 divided by 4 is 1,200. On the level basis, we are producing 1, 2 units. 1, 2, 1, 2, 1, 2. Then aspect of checking for printers, we have the beginning inventory, we have level, okay, the two plans, level capacity with the inventory matching demand. So we are only, for level capacity, we are only just considering the beginning inventory. Down the beginning inventory is 0 for printers. So beginning inventory is 0 for printers, meaning that 0 here. Our ending stock will be 200 when we add these two using the formula for ending stock. The ending stock for the period is a beginning stock for the other period. So this is 200, which is the beginning stock here. So the beginning stock here is 200 plus 1,200. And then minus that, which is 200. So 200 here, we are going to have 0 here. The 0 plus 1, 2 is 1, 2 minus that, which is 0. So the average ending stock here, average ending stock for printers, average ending stock, this is for printers, is actually equal to 200 plus 200 plus 0 plus 0 divided by 4, which is equal to 400 divided by 4, which is equal to 100 units. So holding cost, our holding cost for printers, we are going to have, it is 100 multiplied by the cost of holding printers, the holding cost, the inventory holding cost, the carrying cost is 200. All right, so inventory carrying cost is 200, so multiplying by 200. So meaning that we are going to have the cost of holding printers is 100 by 200, which is 20,000. Then we go for, okay, level plan for the flash. So level strategy, okay, this is for the flash. So for the flash, we have Q1, Q2, Q3, Q4. Then we have our demand, okay. We have, all right, so meaning our demand, then our beginning stock, then we have our production on the level production base, then we have ending stock. Okay, so our demand for flash is 2,000. Then we have 2,4. We have 1,8 and 1,7. The beginning stock, we've been told in the question that the beginning stock for the flash is 450. So 450 is the beginning stock. And our level production is equal to, so level production, we will simply just say is a summation of demand. Okay, so sum of demand divided by a number of periods. So this is what goes on. So meaning that it's a 2000 plus 24 plus 18 plus 17 divide by 4, which is giving us 2000 plus 24 plus 18 plus 17 divided by 4, which is 1975, 1975, 1975, 1975, 1975. So the ending stock for the first month is giving us 425, where we add these. So here it's a beginning stock 425 plus 1975 minus a 24. So this is giving us 0, 0 opening. 1975 minus 18 is 175. Then 175 as beginning in this quarter plus 1975 minus 17 is 450. So finding the average ending stock, average ending stock, ending stock for the flash. So it's actually going to give us 425 plus 0 plus 175 plus 175 okay. Then we have 175. Okay, so 175 plus the other one is the 450. Then divide by 4. So we are simply getting down to what we have. Okay, divided by 4 is 262.1, 262.5. The holding cost, so holding cost is actually going to give us 262.5 multiplied by the holding cost per unit is actually carrying cost is 200 for that was for the printer, then for the flash is 100. So multiply this one by 100. We are getting 26,250. So dollars. So meaning our total cost of level, total cost is equal to printer cost. So printer cost plus the flash cost. So meaning that our printer cost was actually 20,000. So printer cost was 20,000. Then the other cost was 26,250. And then our total cost is actually going to give us 46,250. 46,250. dollars. So this is the cost of the labor capacity. So meaning that what is the actually cheaper is the matching demand. Matching demand is only giving us 30,000. Matching demand is cheaper. That's the conclusion. Okay, so therefore, in this case, matching demand is cheaper than labor capacity. All right, so this marks the end of aggregate planning in terms of this question that we've looked at. So we can end the class for now. All right, so just a matter of going through whatever it is that has been explained. We can end the class for now.